Mathematics is the language with which God has written the universe, said Galileo, because mathematics has everything that shows how beautifully world has been placed or created. But not only Galileo. Long back during 1202 BC, a mathematician named Leonardo Fibonacci had a thought of using Hindu-Arabic mathematics system in the Roman numeral system, and he thought it could be beneficial for Italian merchants. Let's talk about Fibonacci a little bit. Fibonacci was the son of an Italian businessman from the city of Pisa. He grew up in trading colony of North Africa, and during that time North Africa was very much proficient traders, and the traders used to use arithmetic to keep their track of their commercial transactions. But mathematical calculations were made using the Roman numeral system, like I to I, like that, but that system made it hard to do the addition, subtraction, multiplication and division. So while growing up in North Africa, Fibonacci learned the more efficient Hindu-Arabic system of arithmetical. So in 1202, he published his knowledge in a famous book called the Liber Abaci. In this book, he has showed how superior the Hindu-Arabic arithmetic system was, like 1, 2, 3 and everything. So, in this book, the Fibonacci sequence was the outcome of a mathematical problem about rabbit breeding that was posed in the Liber Abaci. The problem was this, like beginning with a single pair of rabbits, one male and one female, how many pairs of rabbits will be born in a year, assuming that every month each male and female rabbit gives birth to a new pair of rabbits, and the new pair of rabbit itself starts giving birth to additional pair of rabbits after the first month of their birth. This was like the written of Liber Abaci books. Now, if we talk about what is Fibonacci sequence, the Fibonacci sequence is a series of numbers like 0, 1, 1, 2, 3, 5, 8, 13, 21, 34. The next number is found by adding up the two numbers before it, like the 2 is found by adding the two numbers before it, 1 plus 1. The 3 is found by adding the two numbers before it, like 1 plus 2. And the 5 is as well has done by the same way, like 2 plus 3. And it goes on. Now, what interesting is that these numbers, this number can make the squares fit nearly together. Like, for example, 5, 8, 13, 8. This makes squares and spirals very much profoundly. We can find the Fibonacci sequence in our nature everywhere, like the flower petals, the snail shells, and the universe, the cosmos itself. So here is a surprise that when we take any two successive Fibonacci numbers, their ratio is very close to the golden ratio 5, which is approximately 1.618034. And even more surprising is that we can calculate any Fibonacci number using the golden ratio. And the answer comes out as the whole number exactly equal to the addition of the previous. Like you can see here, it's a sunflower. You can see its Fibonacci sequence. Like you can make a circle from any portion of the birds, and then it comes Fibonacci numbers, and you can do it from the right side, it will come the Fibonacci numbers, and you can do it from the left side as well, and the outcomes will be the Fibonacci numbers. In geometry, when the golden ratio is applied as a growth factor, you get a special kind of logarithmic spiral named golden spiral. And why so? Because a golden ratio gets wider by a factor of pi for every quarter turn it makes. As for example, we can see the seashells golden ratio structure, and the ocean waves, and the hurricanes, and also the flower petals, also the human ears. Everything is included in this beautiful golden ratio proportion, and for this such property it has been named the divine proportion. Many artists use this ratio in their artwork. Like, they use this, like if we see Mona Lisa, it is also has this golden ratio, and in this pyramid that has been created long before our civilization, it has also this beautiful golden ratio. But many architects also use this ratio when designing buildings and other massive structures. So that's it. That was all about today's Fibonacci sequence. But there has been